Hello, can you hear me?
Hello.
You can hear me, right?
Yes, sir.
Okay, so we'll start the 3D geometry chapter. They have started this in Aleph.
Yes, sir.
How many classes have happened?
3, 2 or 3.
Okay. So
So, and when
basically,
will we do ray optics?
after we finish maths, we have to do probability also. So this is O, this is X, Y, Z. So now there is a point in space. It has coordinates x1, y1, z1. We know what all of this means. It means the point is at x1 distance in the x direction and y1 distance in the y direction and z1 distance in the z direction. Right?
Yes, sir.
So 3D geometry, you will have results which will basically connect your idea of 3D space and also vectors. So we need to know vectors to do this properly. The first thing that we'll see here is basically the distance formula and section formula work as usual. So in 3D space also you can write distance and how to divide the segment between 2 points. So your distance between 2 points will be simply x2 minus x1 whole square and so on, right?
Yes, sir.
And your section formula, again, if your 2 points are divided in the ratio m is to n, then this point P will be calculated using the ratio. So the P coordinates would be m times x2 plus n times x1 by m plus n, and so on for y also, y and z. Right?
Yes, sir.
So your basic stuff that was valid in 2D geometry is the same here in 3D geometry also. Now, the new ideas that will be described here are direction cosines and direction ratios. Direction cosine and direction ratio. So what is a direction cosine? If you have a point in space and its coordinates are given to you, how do you find its direction cosine?
So you can take dot product of like for each in each axis.
Explain properly. What do you mean? I'll take dot product in each axis. Dot product of what? What is the direction cosine of P and how do you find it?
So it's like it's basically the cosine of the angle between the vector and the coordinate axis. So in that vector, you can take it as xi cap plus y j cap plus zk cap. That's that vector R.
And then
So then you can take R dot I, R dot J, and R dot K. So you'll get cos the angle between that, like say alpha, cos beta, and cos gamma.
if you do R dot I, you will get mod R, mod 1 and cos of angle alpha where alpha is the angle between, let's say, OP vector and OX vector, right?
Yes.
So cos alpha will be equal to R dot I by mod R. So R dot I, when you do, you will get just X left on top, and mod R would be just root over X square plus Y square plus Z square, right?
Yes.
So this cos alpha is the direction cosine that is called L, or that stands for alpha is the angle between the position vector of the point and the positive direction of X axis. Similarly, cos beta would be R dot J by mod R. So it will become Y by root over X square plus Y square plus Z square, and that is called M. And cos gamma would be R dot K by mod R. That will be Z by root over X square plus Y square plus Z square, and that is called N. So your LMN become direction cosines of this point. Basically, they stand for the cosines of the angle that the position vector makes with each of the X, Y, and Z axis, positive direction of those axes. So some point could be in space in such a way that it makes some alpha, beta, gamma with the positive X, positive Y, positive Z axis. The cos alpha, cos beta, cos gamma is the direction cosine. And we find it by dot product, and it comes out to be coordinate of that divided by the modulus of the position vector, right?
So
Now, it is obvious from this that L square plus M square plus N square is equal to 1. Because if you do the squares of this and add it, you will automatically cancel out the X square plus Y square plus Z square on top, right?
yes.
So direction cosines will always follow the result that L square plus M square plus N square is 1. So that is your direction cosine. That's how you calculate it. What about direction ratios? What is a direction ratio?
So it's like some multiple of a direction cosine.
Some number ABC which are proportional to LMN basically. So that means A by L should be equal to B by M should be equal to C by N, can be called say K. So any three numbers which are proportional to the direction cosines become direction ratios. So A will be some K times L, B will be some K times M, and C will be some K times N, right?
Yes, sir.
And now, what is the physical meaning of this? So, for example, if you have 2 points, P and Q, and P was x1, y1, z1, and Q was x2, y2, z2. The segment joining P and Q, the segment joining P and Q can be described by the vector PQ vector, which will have coordinate, PQ vector has components x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, right?
Yes, sir.
So this PQ vector determines the direction of this segment, and the numbers x2 minus x1, y2 minus y1, z2 minus z1 determine the direction of the vector. So this can be called as a direction ratio for the vector PQ, for PQ vector, right? Now these
Yes, sir.
numbers, it's not necessary that these numbers will square and add to 1. It is not necessary that they will satisfy the direction cosine condition. So therefore they are called direction ratios, because there's no guarantee that it could be 2i plus 3j plus 4k here, right? So the numbers would be 2, 3, 4. These are not going to be called direction cosines, obviously. So they are given the name direction ratios. They determine the direction of the vector, but they are not like scaled down to have magnitude total 1, right?
Yes, sir.
So from here, if you are given direction ratios, you can easily find direction cosines. You can just divide by each of them by root over 2 square plus 3 square plus 4 square. And that means that the final numbers that you will get will be proportional to 2, 3, 4 because you're dividing by the same quantity. And the squares of these numbers will add up to 1. So these will be your direction cosines. Right?
Yes.
So you can interconvert from direction ratios to direction cosines. Both of the things tell us the direction of a particular vector. If you're using direction cosine for a point, you are telling, okay, what is the direction in which the OP vector is going to be, or the vector from the origin to that point. What is the direction of that vector? You are describing it with the three numbers L, M, N. In case of direction ratios, you're usually going to be describing the direction of a particular segment. And that can be gotten by the difference in coordinates. X2 minus X1, Y2 minus Y1, Z2 minus Z1 becomes the direction ratio. Right?
Yes.
Is this clear?
It is.
Okay, then the next thing we will see, or the first question that we'll see here is this one. Find the direction cosines LMN. Find the direction cosines LMN of a line using the following relations. Using the relations L plus M plus N equal to 0 and 2Mn plus 2Ml minus NL is equal to 0. You have to find the possible direction cosines of this line. These two things are given. And you have to try to find LMN. This is a question that has been asked in JEE Advanced. There are multiple correct answers here. So try to find LMN. If you use the first equation, you can get a quadratic equation. Use the first equation to eliminate one variable. You can say from the first equation, N is equal to minus of L plus M. Right?
Yes.
And in the second equation, if I put that, you will get 2m into minus L minus m plus 2ml minus n into, no, minus n is this, so it will become plus of L plus m into L equal to 0. You get minus 2ml minus 2m square plus 2ml plus L square plus ml. Right?
Yes, sir. Sir, you can also use like L square plus M square plus N square is 1.
How will you use that right now?
So like 3 equations, 3 unknowns.
How will you solve when there are 2 linear equations with mixed variables and 1 quadratic equation? Like, is it easier to solve like this 3 set of equations to find LMN? If it is very easy, just do it. If you try to do anything with this equation right now, it will become very complicated. We will use that condition at the end. Do you understand here what we are doing?
Yes, sir.
We are using first relation to eliminate one variable and we have gotten this quadratic. This has obviously gotten roots because you can say L square plus 2ml minus ml minus 2m square is 0. So you get L common L plus 2m minus m common L plus 2m equal to 0. So you have L minus m, L plus 2m is equal to 0. So you get two possibilities. Case 1 is L is equal to m. Case 2 is L is equal to minus 2m. Right?
Yes, sir.
If you take case 1, when L is equal to m, and you put that in this equation, you will get n is equal to minus 2m, and m can be as it is. So the three things are m, and minus 2m.
Yes, sir.
And now we use the condition that it has to be this. So you will get the value of m now. If you use direction cosine condition now, you will get m square plus 4m square should be 1. So 6m square should be 1. So n square should be 1 by 6. M can be plus minus 1 by root 6. Right?
Yes, sir.
So you'll get two different direction cosines here. One for 1 by root 6, 1 by root 6 minus 2 by root 6. And another is minus 1 by root 6 minus 1 by root 6 and plus 2 by root 6. These are two different possible answers in the case 1 when L is equal to m.
Yes, sir.
When L is equal to minus 2m, we will do similarly. If L is minus 2m, we'll write minus 2m. M is same as m, and here it is minus m. So it is plus m, right?
Yes, sir.
And now again we use this condition to get, you'll get 6m square is equal to again 1. Again plus minus 1 by root 6. So the direction cosines will become minus 2 by root 6, 1 by root 6, 1 by root 6, and 2 by root 6, minus 1 by root 6, and minus 1 by root 6. Are you understanding what is happening?
Yes, sir.
So you have 4 possible direction cosines. We are doing it by simplifying the equations which are simpler. Like if you try to do directly 3 equations, 3 unknowns, it will take a long time to simplify. I don't know how you will simplify also. You have to just use these two to get this result. If you get this, after that you can use the final thing in the last step because you know the ratios.
Yes, sir.
Is it clear?
Yes, sir. Got it.
Okay, then the next thing in the theory is angle between two line segments. So that is pretty straightforward between two line segments. And if the line segments are given with their direction ratios, one that line segment has direction ratios this, and the other line segment has direction ratio this. So basically direction ratio shows the vector along the line, right? So this is line 1, this is line 2. A1, B1, C1 is the coordinates of this segment, right?
Yes.
So if you want direction between two vectors, the best way to do is a dot product of the two vectors, right? Like this vector, because direction ratios are given, these are direction ratios. The L1 vector can be written as A1 I cap plus B1 J cap plus C1 K cap. And this vector can be written as A2 I cap plus B2 J cap plus C2 K cap. Because direction ratio tells us the difference between 2 points on it. So that is the direction of the line. Are you understanding what I'm saying?
Yes.
So obviously angle between the lines cos theta would be the dot product of these two vectors divided by the mods, right?
Yes.
So it will be A1, A2, B1, B2 plus C1, C2 divided by root over A1 square, B1 square, C1 square into root over A2 square, B2 square, C2 square. If you don't divide the mods, it will be wrong because dot product does not have to be, the top part does not have to be between -1 and 1. Dot product divided by the mods, that will give you the cos theta, which is the angle between the two segments.
Yes.
If somebody gave you direction cosines of the line, then you don't need to divide because automatically these will be 1 and 1, right?
Yes.
If direction cosines of the lines were given, the answer would have been simply L1 L2 plus M1 M2 plus N2, N1 N2, right?
Yes.
So this part is pretty obvious because that's how we define the meaning of your direction ratios and direction cosines. Now, from these formulas, we can easily say basic things like when will two lines be perpendicular, when will they be parallel, and so on. So lines are perpendicular if this part is 0, right?
Yes.
If your direction dot product is 0, then theta is 90. So a1 a2 plus b1 b2 plus c1 c2 is 0. Or if it was given in terms of direction cosines, l1 l2 plus m1 m2 plus n1 n2 is 0. If lines are parallel, by that I mean the in that case the angle could be what? What is the
0.
angle? Could be 0 or pi, something like that, right?
Yes.
Vectors could be parallel or anti-parallel, but cos theta would be 1, right? Or
Yes.
-1. You can take mod and all. So what will we get then? We'll get 1 is equal to this. So you can simplify this and prove that lines are parallel. The condition will be A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Basically, all the direction ratios will become proportional.
Yes.
Lines are parallel. How do you prove that? This has been discussed in class for you, right?
Yes.
What is the proof for that?
Sir, it's the same as writing L1 is equal to L2, M1 is equal to M2, and N1 is equal to M2.
I'm asking you for the proof of this from here. How are you talking about L1 is equal to L2 and all? You are given direction cosines which are different, and you have to prove that they are parallel. Direction ratios are given, they are different values. You have to prove that the lines are parallel. Why are they parallel if this has to, if, why is this the condition for being parallel? Do you know the reason why it is this, or you don't know?
So like it wasn't proved, but I can probably do it.
How will you probably do it?
So I'll have to try.
What are you trying? What will you start off with? You have to start off with cos theta equal to 1. This is 1 if they are parallel. Then you will get
Yes, sir.
1 is equal to a1 a2 plus b1 b2 plus c1 c2 by root over a1 square plus b1 square plus c1 square multiplied by this. If you square and take it to the other side, you will get a1 square plus a2 square plus b2 square plus a1 square plus b1 square plus c1 square multiplied by a2 square plus b2 square plus c2 square is equal to a1 a2 plus b1 b2 plus c1 c2 whole square. Right?
Yes, sir.
Expand the left hand side, you will get a1 square a2 square and terms like b1 square b2 square c1 square c2 square. Those terms will cancel from the first three terms of this, right?
Yes, sir.
The terms that will be left over on that side will be a1 and b2, a1 and c2. So you can write a1 square b2 square plus a1 square c2 square plus b1 square a2 square plus b1 square c2 square. And again c1 a2 will be left over and c1 b2. These are the terms that will be left, right?
Yes, sir.
3 terms will cancel, 6 terms will remain out of the 9 terms. It is equal to, you will get 2 times a1 a2 b1 b2 plus 2 times a1 a2 c1 c2 plus 2 times b1 b2 c1 c2. Right? Is that clear?
Yes, sir.
If you bring these 3 to this side, you will be able to combine this, and this, and it will become a1 b2 minus b1 a2 whole square. And similarly, you'll be able to combine this, and this. And that will become a1 c2 minus c1 a2 whole square. And lastly, b1 a2, no, b1 c2 minus b2 c1. b1 c2 minus b2 c1 whole square is equal to 0.
Yes, sir.
So sum of 3 squares will be 0 only if individual squares are 0. So you'll get a1 b2 minus b1 a2 is equal to 0, which implies a1 by a2 is equal to b1 by b2 equal to c1 by c2 from other brackets. Is it clear?
Yes, sir.
So the condition for parallel lines is this. It comes from your cos theta equal to 1 in the dot product. After simplifying a little bit, this is what you get. Right?
Yes, sir.
Then the next thing is projection of a line segment on a line. So projection of a line segment on a line. So the idea here is similar to what we saw in vectors. So let's say we have x1, y1, z1 is point P and Q is the point x2, y2, z2. We want to find out projection of PQ segment on line L whose direction cosines are LMN with DCs LMN. So this is pretty simple. If you have the segment here, P and Q, this is your P and Q. The points are given. So this vector is known. This is x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, right? And
Yes, sir.
a line could be in another direction. L, M, N are the direction cosines of the line. So basically this line is in the direction L I cap plus M j cap plus N k cap, right? That is your B vector for the line. B vector, basically what I mean is R is equal to A plus lambda B. We saw line equation was like this where it was passing through A and parallel to B. So B is the line here, right?
Yes, sir.
Is it clear what I'm saying? The line's direction is given by the direction cosine vector, right?
Yes, sir.
So projection would be what is the portion of this line that is incident on this? So PQ cos theta, right? Suppose they make an angle theta here. I want to find out what portion of PQ is on this line, right? Correct.
Yes, sir.
Projection of vector A on vector B is always A cos theta, right? Vector A on B, projection of
Yes, sir.
is A cos theta, and basically projection of this vector on this vector would be this cos theta, the mod of this. So you will get this cos theta thing can be calculated by doing A dot B and dividing by mod B. That will be equal to A cos theta, right?
Yes, sir.
So dot product of these two vectors will be L times x2 minus x1 plus M times y2 minus y1 plus N times z2 minus z1 and divided by mod of B. Mod of B is 1 only because direction cosines were given. If direction ratios are given, mod of B will be something, right?
Yes, sir.
And then you take the mod of this because you want a positive value, which is the distance in real. Distance should be positive. Dot product could have been negative. That distance, the positive value of that distance is the projection, right?
Yes, sir.
Now suppose we have a question like uh, find the projection of the, okay, so same question. Points are 1, 2, 3 and -1, 4 and 2. These are the 2 points. You want projection of PQ on line with direction ratios. Direction ratios are 2, 3 and -6. Find the answer. Projection of this.
So you have to do AB dot PQ by mod PQ.
Find the answer. I'm asking the answer. Don't tell me what to do. I know what to do. What is coming?
Sorry, 8 by 7.
That's correct. You have to take PQ dot line vector by mod of the line vector, right?
Yes.
Because this is direction ratios, mod is not 1. If it was direction cosine, we don't have to do this. And the final thing you have to take mod because it is a positive length, right?
Yes.
Then we look at equation of a plane in 3D. Equation of a plane has been done in class.
Yes, sir.
So when we talk about a plane, we mean something like this. And when we say a line is in the plane, a line is in the plane, that means that all points on the line are part of the plane, every point. That means a line is in the plane. If it is crossing the plane, it will cut the plane at only once, right?
Yes, sir.
If it is in the plane, it will be completely in the plane. So all the points will be in the plane. So first thing that you should know is that any two lines can define a plane together, right?
Yes, sir.
Because no matter how the lines are, you can always take a common plane between them, right? You can always figure out a plane which will be basically containing those two lines, right?
Yes, sir.
So now if you have a plane like this, the way we define the equation of a plane using vectors is we take a point lying on the plane. So let's say origin is somewhere, and let's say this point is A with position vector A. And we say that we have to take an arbitrary point in the plane. This is R vector, arbitrary point. This is like your general point on the plane. X I cap plus Y J cap plus Z K cap. This is a given point, right? And then we say that there will be a particular direction which is normal to the plane. So we have to define a normal direction to the plane. So this normal vector is your normal direction. You can take a unit vector of that also. So that is always perpendicular to the plane. That means the normal will be perpendicular to all the lines that are in the plane, right?
Yes.
Normal is perpendicular to all points in the plane. You can lift up the vector and put it here. It will be perpendicular to this, anything that is in this plane, right? So what we can say in general is this arbitrary point on the plane and the known point on the plane will define a segment. This segment will be your r minus a vector. The r minus a vector or line segment is completely in the plane, right?
Yes.
Because we have taken a point on the plane and another arbitrary point on the plane. So it's definitely going to be in the plane r minus a. So r minus a is in the plane. So it must be perpendicular to the normal. So r minus a dot product with normal unit vector should be 0, right?
Yes, sir.
So if you know the normal direction and if you know a point on the plane, then you can define the equation of the plane. Because what you'll get is r dot n cap is equal to a dot n cap. So this will become some distance because it's a scalar, and this will be r dot n, which will come in terms of x and all, right?
Yes, sir.
Because r dot n, suppose n was some 2i plus 3j by root over 13. So you will get 2x by root 13 plus 3y by root 13 is equal to a dot n whatever value, right? So that will define a plane now. Are you understanding?
Yes, sir.
So your equation of the plane is r dot n cap is equal to a dot n cap using vectors. And that comes from the fact that r minus a line segment is completely in the plane. And you need to know two things for defining the equation of the plane. You need a point on the plane and you need the directions of the normal vector, right?
Yes, sir.
And r stands for any general point in this plane. R is the variable point by which the equation is defined. So if you understand this, then your plane stuff in 3D should be easy. The first form of plane equation that we will see is your normal form of plane equation. And we will see several different forms of plane equation. It is similar to how we see several different forms of line equations in 2D coordinate geometry. So normal form of plane equation is this: Lx plus my plus nz is equal to p. Here L, M, N are direction cosines of the normal to the plane. And P is the distance or perpendicular distance from origin to the plane. You need to know these things like what is what, otherwise it will be totally confusing. In this equation, version of the plane equation, LMN stands for direction cosines of normal to the plane and P is the distance from origin to the plane, right? And this comes
Yes.
directly from the thing that we just now did, because we got r dot n cap is equal to a dot n cap, right? And r could be in general xi, yj, zk, xi plus yj plus zk. And n normal direction, since we know the LMN are direction cosines of normal, so that is definitely Li plus mj plus nk, right?
Yes, sir.
Is equal to something a dot n. So that we'll figure out later. But this side is becoming Lx plus my plus nz, right? Is equal to some a dot n, right?
Yes, sir.
So now how is this A dot n equal to the perpendicular distance from origin to the plane? That we have to understand. So if this is the plane, and let's say origin was here, and A was a point on the plane, right? This was A vector, position vector, right?
Yes.
And if the perpendicular direction is this is my n cap, which is Li plus Mj plus Nk. This is my perpendicular direction. So this direction is theta, this angle, right? So when I'm taking OA dot n cap, right? I'm basically taking the angle between OA vector and n vector, this angle, right?
Yes. Sir.
OA dot n cap is what? Is going to be mod OA mod n cap cos theta, where theta is the angle between the two lines, right? So if you think about it, mod OA is this distance r, right? And mod n cap is 1. So it is r cos theta, where theta is the angle between the vector A vector and the n vector, right? In this case, we are getting an angle which is bigger than 90. That's fine. If you take this theta angle is 90 plus alpha, where alpha is this portion, right? So what is this angle? This angle is 90 minus alpha, right?
Yes.
Correct. So cos theta, r cos 90 plus alpha will come out to be minus r sine alpha, right? Correct.
Yes. Sir.
And r sine alpha, if you see in this triangle, in this right angle triangle, cos 90 minus alpha is sine alpha. So r cos is going to be this distance, right? This distance is basically r sine alpha,
Yes. Sir.
because cos of 90 minus alpha is sine alpha, r sine alpha is this. So notice that that is the perpendicular from the origin to the plane, right?
Yes. Sir.
So this r sine alpha is becoming the perpendicular distance. If you do the dot product of OA dot n cap, you are getting perpendicular distance from origin to plane. The negative sign is coming because the angle was obtuse. So when I write the equation Lx plus My plus Nz equal to P, this P, the mod of P represents the distance from origin to plane. Are you understanding?
Yes. Sir.
It is the same thing as saying r dot n cap is equal to a dot n cap. When we did the vector equation, r minus a dot n cap is 0. Both of these are equivalent things. It's just written in a different way. Here n cap's direction is Li plus Mj plus Nk. The direction cosine of the normal was Lmn. Is it clear?
Yes. Sir.
We will see other forms of the plane equation. Go through the chapter, whatever has been done, go through your Allen book. Plane equation is there, then we have a little more theory, maybe two or three classes max. We should be able to finish this chapter. So go through the theory once so that we can do it faster. Right? There are many
Yes.
forms of plane equation that will be given in your Allen book. Go through all of that, go through the beginner boxes, and we'll continue from this point.
Thank you, sir.
Bye.